DC voltage and current measurement using TMS320. Welcome to another informative post from evhub.com. This article will delve into battery voltage measurement using the TMS320 F28069 microcontroller. We'll walk you through the provided code step by step and explain the process of calculating battery voltage using a detailed formula. So, let's get started. Introduction. A key component of many electronic systems, especially those that use batteries for power, is battery voltage measuring. We can precisely measure battery voltage thanks to the analog to digital converter, ADC, on the TMS320 F28069 microcontroller. The included code provides a thorough formula for calculating the voltage and an example of how to interact with the ADC to measure battery voltage. The battery, powering the EV revolution. Electric vehicles have been making waves globally, and their impact on the automotive industry is undeniable. At the heart of every EV is its battery, and understanding its role is essential. Battery types. Lithium-ion batteries. These are the most common battery type in EVs due to their high energy density and efficiency. Solid-state batteries, emerging technology that promises higher energy density, longer life, and faster charging. Nickel metal hydride, NIM, batteries, used in some hybrid vehicles for their reliability. Hydrogen fuel cells, an alternative to traditional batteries, converting hydrogen into electricity on the go. Section 1. Understanding the battery voltage calculation formula. Let's begin with the heart of our measurement process, the battery voltage calculation formula. We'll explore it in depth and break it down step by step. Battery voltage calculation formula with offset. Battery voltage in volts equals ACK result, offset count, multiplication factor, ACK_resolution, offset count. Here's what each component means. ACK_result. This is the raw ACK reading for the battery input voltage. ACK_resolution. The maximum possible value of the ACK reading, 4095 for a 12-bit ACK. Offset_count, an essential factor when dealing with offsets, and we'll calculate it shortly. Multiplication_factor, in our case, it's 750 volts, but it can vary depending on your setup. Battery voltage calculation formula without offset. Battery voltage in volts equals ACK result, ACK resolution, maximum battery voltage. Now, let's move on to some practical examples. Section 2. Practical examples without offset. In this section, we'll put theory into practice. We'll calculate battery voltage for different ACK results using the formula. It's all about understanding how to apply this knowledge in real-world scenarios. Example 1, ACK_result equals 2048, mid-scale. Let's calculate the battery voltage step by step. Battery voltage in volts equals 2048 to 0, 750. 4095 to 0 equals 2048 times 750. 4095. 375.61 volts. So, for an ACK_result of 2048, the estimated battery voltage is approximately 375.61 volts. Example 2, ACK_result equals 1024, 1/4 of full scale. Now, let's calculate the battery voltage for an ACK_result of 1024. Battery voltage in volts equals 1024 to 0, 750. 4095 to 0 equals 1024 times 750, 4095, 187.81 volts. The estimated battery voltage for an ADC_ result of 1024 is around 187.81 volts. Section 3, Practical Examples with Offset. What happens when we introduce an offset voltage of 0.2 volts into the mix? We'll adjust our formula accordingly and calculate battery voltage once more. Example 1, ADC_ result equals 2048, mid-scale. Let's calculate the battery voltage step by step with the offset. Calculating offset_count. Offset_count equals offset voltage, ADC maximum voltage, ADC resolution. Offset_count equals 0.2, 3.294, 4095. 248, 8.76, rounded to the nearest integer, which is 249. Calculating battery voltage with offset. Battery voltage in volts equals 2048 to 249, 750. 4095 to 249 equals 1799 times 750, 3846. 351.28 volts. For an ADC_ result of 2048 and an offset voltage of 0.2 volts, the estimated battery voltage is roughly 351.28 volts. Example 2, ADC_ result equals 1024, 1/4 of full scale. Now, let's calculate the battery voltage for an ADC_ result of 1024 with the offset. Calculating battery voltage with offset. Battery voltage in volts equals 1024 to 249, 750. 4095 to 249 equals 775 times 750, 3846. 151.33 volts. For an ADC_ result of 1024 with an offset voltage of 0.2 volts, the estimated battery voltage is approximately 151.33 volts. Section 4, the final code. To wrap it all up, we'll provide you with a final code that integrates all the knowledge we've shared today. With this code, you'll have the tools to measure battery voltage and current with precision. Join us on this electrifying journey into the world of DC voltage and current measurement using the TMS320 F28069 microcontroller. Whether you're an electronics enthusiast, a student, or a professional engineer, this video is your gateway to mastering these crucial skills. Don't forget to like this video, subscribe to our channel for more exciting tech content, and hit that notification bell so you never miss an update from EVHub.com. Let's elevate our electronics game together.